Let's have a go at naming this molecule. The first step is to identify the parent chain. That's the section of the molecule with the longest series of carbons uninterrupted by another atom. So one carbon attached to the next carbon, attached to the next carbon, etc., etc. If we look at this specific molecule, we'll see there are 6 carbons attached to each other. But there are 2 possible paths where there are 6 carbons attached to each other. So which one of these is the parent chain? Well, when we're stuck with the same number of carbons and we have 2 paths, the next thing we look for are the number of branches off each potential parent chain. That's to say, the number of attachments to each one of these chains. So on the left-hand side, you'll see there are 2 branches on this particular chain. On the right-hand side, you can see there is 1 branch off this chain. The parent chain will always be the chain with the most branches off it, where 2 or more chains have the same number of carbons present. So our parent chain is the left-hand version of the molecule. The next thing we need to do is to identify the position of the branches, or the functional groups that are attached to the parent chain. We can number from left to right, or alternatively, we can number from right to left. But which is correct? Well, we now need to think about giving the lowest possible number to a branch. If we number from left to right, the lowest number is going to be 2. If we number from right to left, the lowest number now is going to be 4. 2 is lower than 4, so the correct numbering sequence goes from left to right. Thirdly, we want to name our functional groups that are attached to the parent chain and then place them in alphabetical order. So let's look at those functional groups. We have a methyl group at position 2 and an ethyl group at position 3. So this isn't in alphabetical order yet. Let's look at M and E. E comes before M in the alphabet. So we're going to name E for ethyl first, despite the fact it's on position 3 and not on position 2. So the actual name of this molecule is 3-ethyl 2-methyl hexane. So what's important here that we've learnt is where there are 2 potential parent chains with the same number of carbons, we need to count the number of branches on each potential chain. And it's the chain with the largest number of branches that becomes the parent chain.